Okay, so our next problem that we're going to be working are going to be moles of compounds one step, and they're going to be worked out the same way that we did the elements, except when we're doing our molar mass, this time, or our mass problems, we have to use molar mass of compounds, which is going to be a little extra work. And when we're looking at atoms, we're looking at molecules with compounds, and instead of writing atoms, we just write molecules. So let's take a look at our first problem of moles of compounds one step. So we're looking at 1 through 10, and we're converting all of these over to number of moles. So in number 1, we'll put a question mark, moles, and we are working with CO2. And what do we know about CO2? We have 6.02 times 10 to the 23rd molecules. So you can abbreviate molecules MOLCS, okay? You don't have to write all molecules, but please don't write M because M stands for meters, okay? Then we draw our equality. Just like before, if we want molecules to cancel like we did with atoms, we put it down here in the bottom. If we look at our mole diagram, we're starting here at molecules and we can only go to moles. So that's what we're going to put in the top of our equality. Will be moles of CO2. And just like our element 1, it's still 1 mole. And in our mole diagram, we're using our 6.02 times 10 to the 23rd. Molecules will then cancel out and you're left with moles. So just like before, we would take our top numbers and multiply. So 6.02 times 10 to the 23rd times 1 is itself. And we carry over the number that's in the bottom. So that's 6.02 times 10 to the 23rd. And our answer is going to be 1 mole of CO2. So number 1 will be a model for 2 through 5. They'll be set up and solved the same way. You'll just have a different number of molecules that you're starting with, but you'll still use the Avogadro's number and 1 mole for your equality to solve. Let's take a look at number 6. So with number 6, again, we're still trying to find our number of moles. And we are working with NH3, ammonia. And we know we have 34 grams. Okay, so what we're trying to find equals our number of grams. Let's draw the equality. Just like before, if we want our grams to cancel, grams will go down in the bottom. Let's look at our mole diagram. So we are starting off here at grams and we're traveling 2 moles. We're going to use our periodic table to find our mass. And if we set it up correctly, we'll be dividing by our molar mass of our number of moles. So we go to our periodic table and remember to find, and I'm just going to work this one out real quick. We're looking at the formula. We have nitrogen. We have 1 nitrogen. And we go to the periodic table. The mass of nitrogen is 14. We round that to 14. Hydrogen, we have 3 hydrogen. We go to the periodic table. Hydrogen's mass, we're going to round to 1. Multiply across. Add going down. So that's the mass that we use here, the molar mass. Okay, so we put 17 in there. Since we're going to moles, moles will go in the top. Grams will cancel out. So you take 34 times 1, which is 34. Carry over this bottom number, 17. So we end up with 34 divided by 17, and we get 2 moles of NH3. Number 6 will be a sample for for number 7 through 10. Okay, they'll be set up and solved, but you'll be using different compounds. So you'll have to use your periodic table to calculate the different masses to put in here for the number of compound, but you'll still be using the 1 mole over that molar mass that you calculate. Number 11. This time we're going to find mass. It says convert to mass, so we're going to put question mark grams. And specifically, we're working again with NH3. What do we know about NH3? Well, we're given 5.0 moles of NH3. And I'm just going to put the 5. We don't have to worry about 5.0. Okay, if we want our number of moles to cancel, that will go in the bottom of our equality. And we go to our mole diagram. And so we're starting at moles and we're going to grams. So this time we should end up multiplying by our number of grams. Our last time we divided. Okay, so since we're going 2 grams, grams will go in the top. And yes, that looks like we're going to be multiplying. 1 will always go with our number of moles here. And like I said, we calculated our mass of NH3 in our last problem, so we'll go on and put 17 there. So we're going to take 5 times 17, and that will give us 85 grams. Oops. We'll take this 1, so 85 divided by 1, and our answer is 85 grams of NH3. Okay, again, you need to show your work because in 2-step problems, it's not always going to be over 1. Okay, so practice setting up the 1 step. You will be so happy that you did. Okay, so 11 is going to be a model for 12 through 15. Finally, number 16. With 16, we're trying to find our number of molecules. So go question mark MOLCS for molecules, or MOLC, that's fine. And we're working with CO2 in this problem. What do we know about CO2? We have 2 moles of CO2. So if we want moles to cancel, moles will go in the bottom. Where are we going to? Well, let's go to our mole diagram to see. So we're going moles down to molecules. So where we're going to will go in the top. So molecules will go here. The number 1 will always go with your number of moles. We look at our mole diagram. We're using Avogadro's number, the 6.02 times 10 to the 23rd. So we'll take 2 times 6.02 times 10 to the 23rd, and we get 1.24 times 10 to the 24th. Carry over that 1, so we divide, and we end up with 1.24 times 10 to the 24th molecules of CO2. So 16 is going to be a model for 17 through 20, where we're using Avogadro's number again, and we're labeling with molecules instead of atoms.